Alright, so here's another example on the x-intercept form as you required in class, which you want a little bit more explanation on this. Now I'm going to show this to you. So you can see already listed x-intercept form on the top, which is a and then two bracket, and inside the bracket we have x minus x1, x minus x2, and then below it you can see the example that we're going to go through together. So remember, if I want to sketch in graph, there are four things I need to determine. So the first one is either concave up or concave down. So I'm just drawing a really quick quadratic graph over there to show you that. And which part determine whether it's going up or down is the a value. So that is why later we need to decide the a value. Secondly, we need x-intercepts, which very likely we already have everything listed here. Step 3, that will be the y-intercept. And then the fourth step, turning point. So those are the things we need when we sketching the graph. And then in this case, you can see a equals to negative a half. So if it's negative a half, then we know your graph is facing down and it's going to be like a wider graph. So then the first thing we determine is, yes, it's going to be concave down. And then x1 equals to what? So if sometimes you get really confusing with, well, we have negative here, we get negative here, how got the positive here, how can I determine whether it's positive or negative? Either way is trying to make the bracket into 0. So if you have plus 6, how can I make this bracket back into 0? I need to minus 6. So that is why x1 is minus 6. And the second one, if you have x minus 4 in the bracket and I want to make the bracket as 0, so what can I do? X equals to 4. So then that means your x2 equals to 4. When I have these two different values, we determined our x-intercept as well. So we have negative 6, 0, and 4, 0. So before we're doing the y-intercepts, because that's going to be quite easy, we're going to start with the turning point first. So how do we actually do the turning point, guys? Like I said in the previous one, we don't really need a symmetry formula in this, which is the negative b over 2a. We don't need in that one, because we can determine our symmetry immediately with the x-intercepts. Why is that happening? So if I'm going to draw the graph, half of the graph, like not all of them, let's just determine whatever we have on the x-axis at the moment. So we have negative 6. So if I put 0 over here, that is 0. And if I have negative 6 on negative side, and then slightly smaller part over here for the positive 4. Then you can see we got the distance is between 0 to negative 6. We got 6 units. 0 to 4, we got 4 units. So 6 plus 4 units, I got altogether 5 of them. So 5 units in between. And then how can I determine where is the middle point? We're adding them up, divide by 2. So then we're adding them up gives me negative 6 plus 4 equals to negative 2. And then all of these divided by 2 gives me negative 1. So that means, so I need to actually take over that. So let's get rid of this. Why is not getting rid of? Why it's not working? Okay, I'm not really sure why it's not working, so let's just leave it here for now. It doesn't really want me to work for eraser. So yes, let's see. So now we can see in between we got negative 6 to negative 5, we got 5 units. Yeah, my writing is way too much. Way too terrible, so then I'm going to write it better. 5 units. And then from negative 1 to positive 4, so we got 1 unit, 4 units, altogether 5 units. So then easily you can see that is my symmetry, that is my turning point, the x value of my turning point. So that means in one of the turning points we already got, the x value is -1. How about the y value? Very easily, we substitute x equals to -1 back into my question over here. So my equation or my function over there. So when for a turning point, let's do turning point first. Turning point x value we already know, so x equals to -1. Then y equals to -1/2. Then x being replaced by the value -1 plus 6. And then -1 minus 4. So then the whole thing becomes to what? Y equals to -1/2. Then here we got 5 times 5 times -5. So then eventually we have y equals to, you can either use the fraction or decimals, it's really up to you, but this one I think decimals will be easier because 5 times 5 gives me 20. So 5 times -5 gives me -25. Negative gives me a positive. 25 divided by 2 gives me 12.5. So that's why y equals to 12.5. That means your turning point is 12.5. And then the y-intercepts will be very easy thing, like be very, very easy too. So y-intercepts equals to y-intercept. So remember, in the y-intercept, which part equals to 0? So if we know x-intercept, we have the x value and 0. Y-intercept will be have 0 as the x value and something in the y value. So that means we need to make x equals to 0 this time to find y-intercepts. And then we have y equals to -1/2, and then we have 0 plus 6, and then 0 minus 4. Then this will be quite easy because 6, so that will be 1/2 times 6 times -4. Then we have negative gives me positive, and then 24, so 6 times 4 is 24 divided by 2 is 12. So now you can see the y-intercept is 0 and 12. So now we have all of the information we need. We can continue. So remember, so I'll go a little bit further down here. Then you have the graph x and y. And then remember my x-intercept. So firstly, it's concave down, so it's facing down. And then we have x-intercept is -6 and 4, so we can do -6 somewhere here, -6, and then 4 over here, and then your turning point. So this TJ is not JP. Sorry, my mistake. So TP is -1 and 12.5. So remember this one, because the graph is concave down. That basically means we are having the maximum turning point. So that means the graph can reach to the maximum instead of minimum. We have -1 and 12.5. So that means -1 will be somewhere here, -1, 12.5. Let's just make here as 12.5. And then because later we need to do the y-intercept, so let's just make 12 here for the x-intercept. So that means your turning point is here. And then your y-intercept is here. X-intercept are here. All you need to do is connecting them with a curve. Sorry, I'm not doing a really good graph, but basically you can see. Then the graph somehow look like this. So if you can use rulers, that'll be even better, but here I don't really have a ruler to use, so that's why. Then you can see for the x-intercepts how we solve, how we sketch, how we make each of the determining elements, that's all of them. So hopefully this will help you to understand this one better.